Have you ever wondered how we actually know all the stuff we know about how people grow up? Well, in this explainer, we are opening up the secret toolbox the developmental psychologists use to understand the biggest mystery of all, us. Let's get right into it.
So how do we get from just kind of watching people to building these big complex theories that explain our entire lives? It really all starts with having the right tools for the job. And we're going to break down exactly what those tools are and how they're used.
All right, first up, every single investigation needs a way to gather clues, right? For researchers, this means picking the perfect method for collecting data. So let's look at the foundational tools they use to watch and to ask questions.
The first tool in the kit is something called systematic observation. Now, this is not just casual people watching at the mall. Nope. It's a really rigorous method where researchers carefully, and I mean carefully, observe and record very specific behaviors. But as you're about to see, where you decide to do your watching makes all the difference.
And this right here lays out a huge trade-off. On one hand, you've got naturalistic observation, watching kids in a real daycare. You get authentic, totally unfiltered behavior, but it's messy, it's unpredictable. On the other hand, in a lab, a structured observation gives every single participant the exact same setup. That's fantastic for comparison, but you've always got to wonder, is that behavior truly natural, or is it a little bit, put on for the show? Of course, you can't see everything. That's where the next tool comes in, self-reports. This is all about the power of simply asking. It lets researchers get inside a person's head to understand their thoughts, their feelings, their personal experiences, all the stuff that observation alone could never, ever reveal.
And yeah, this visual really captures the whole idea. Watching can tell us what a child does, but only a self-report can tell us why they feel sad or what they dream about. It's the only tool that really opens a direct window into that rich internal world that we all have.
And just like with watching, there are different ways to ask. A clinical interview is really flexible, almost like a guided conversation, which lets a researcher follow interesting ideas as they come up. You get incredibly rich info. The downside? Well, people might not remember things perfectly, or sometimes they say what they think you want to hear. A structured questionnaire solves that by asking everyone the exact same things, which is great for comparing answers, but you definitely lose some of that conversational depth.
Okay, so you've got your tools for collecting the data. Now you need a blueprint, a research design. This is the master plan that's going to guide how you put those tools to work to answer your big question.
Now this is a huge one. You have to choose the right plan for your goal. A correlational design is perfect if you're just asking, do these two things seem to be related? But, and this is so important, it can never, ever prove that one thing causes another. For that, you absolutely need an experimental design, which is built specifically to answer that tricky question of cause and effect.
When we talk about correlation, what we're really talking about is a number, the correlation coefficient. It's this neat little score that goes from -1 all the way up to +1, and it tells us two simple things: how strong is the relationship and which direction is it going.
For example, a number like +0.98, that is a very strong positive correlation. It basically means that as one thing goes up, the other thing almost always goes up right along with it. They move together in the same direction.
And then on the flip side, you get a number like -0.81. That's a strong negative correlation. In this case, as one variable goes up, the other one consistently goes down. They move in opposite directions, just like a seesaw.
Now, to actually prove cause and effect, we turn to the experiment. The logic is simple, but it is so powerful. Researchers take one thing, the independent variable, and they actively change it. Then they just sit back and watch to see if that change has an effect on another thing, the dependent variable. Think of it like this. Does changing the amount of sleep someone gets, that's the independent variable, affect their test scores, the dependent variable? That's an experiment in a nutshell. So far, so good, right? But developmental psychology has this one huge, unique challenge. You can't just stick someone in a time machine. So how in the world do you study change that happens over months, years, or even decades? Well, one solution is the longitudinal design. You can think of this as the ultimate long-term commitment in research. You find one group of people and you study them over and over again across a long stretch of time. You check in at age 2, then again at 4, then 6, and you just keep going. But man, that takes a long time and a lot of money. The faster alternative is what's called a cross-sectional design. For this, you study different age groups, say a group of 2-year-olds, a group of 4-year-olds, and a group of 6-year-olds all at the same time. It's way more efficient,
but you can't see how one individual changes. Plus, you risk what are called cohort effects. Like, are today's 6-year-olds different from today's 2-year-olds because of their age? Or is it because the 6-year-olds grew up without iPads? That's a cohort effect.
So how do you solve this whole puzzle? Well, this is where the sequential design comes in. It's a really clever way to get the best of both worlds. By following several different age groups over time, researchers can double-check their results, spot those tricky cohort effects, and be way more confident that the changes they're seeing are really about development.
Okay, we've covered the tools and the blueprints, but there is one last part of the toolkit. That's, well, you could argue it's the most important piece of all. The ethical compass that guides every single decision a researcher makes.
This quote from the American Psychological Association: "This is the bedrock of all research. The well-being of the people in the study is completely non-negotiable, and this is especially critical when you're working with vulnerable people like children or the elderly, who might not be able to speak up for themselves in the same way."
And these are not just suggestions. They are hard and fast rules. For any child, a parent must give consent. But for kids over age 7, researchers also respect them enough to ask for their consent too. And similarly, for older adults with cognitive impairments, a caregiver or a surrogate has to provide that consent. The goal is always, always to protect those who can't fully protect themselves.
And researchers aren't just left alone to figure all this out. Before any study can even get started, it has to be approved by an institutional review board, or an IRB. These committees act as a critical checkpoint, making sure every study is designed ethically from the ground up, and learning from the history where, frankly, that wasn't always the case.
So now that you're armed with the blueprints of research, you're better equipped to be a critical consumer of science. The next time you see a headline about some new study, maybe you'll ask, wait, was that correlational, or was it a real experiment? Was it longitudinal? Because knowing how the clues were gathered, that's the key to understanding what they really mean.